Okay, in this example, I want to just discuss the sum, difference, and constant multiple rules. This theorem makes it look a lot more scary than it really is. All it's saying is that if you have two functions f and g and you have the sum of them, then when you take the derivative of the sum, it's the same as the sum of the derivatives. So for example, let's say f of x was x cubed and g of x is something like x squared, then the derivative of f of x plus g of x, or x cubed plus x squared, is the derivative of each one of those pieces separately, and you just add them up. So that will be 3x squared plus 2x. So that's how you handle sums. Now, for differences, we take the derivative of a difference is the same as the difference of the derivatives. So again, if f of x is x cubed and g of x is x squared, then f of x minus g of x is x cubed minus x squared. And if you wanted to take the derivative of that, so if you're taking the derivative of x cubed minus x squared, that's the same thing as taking the derivative of x cubed minus the derivative of x squared. And so in this case, you get 3x squared minus 2x. Okay, so that's the sum and the difference rule. And then the final rule is the constant multiple rule. And that just says if you have a constant times your function, then and you want to take the derivative of that, the same as you can just pull the constant out front and then take the derivative. So for example, let's say I had 3 times f of x, which in this case would be 3 times x cubed. If I want to take the derivative of that, it says it's the same thing as doing 3 times the derivative of x cubed. And usually I write that in a different color. Okay, so that will give us what? That will give us this 3. And then when I take the derivative of x cubed, I get another 3x squared. So it ends up being 9x squared. Okay, so these rules actually tell you that the derivative is about as nicely behaved as you would want it to be when it comes to sums, differences, and constant multiples. It behaves exactly as you might expect. Okay, so that's it for now.